So good morning to you all. Good morning.
Good morning.
Good morning, sir.
Hope you're all well. And there are no COVID cases among your class or your classmates.
Good morning, sir.
Good morning. So I'm still waiting to see how many people join. So far, we just have about 35 participants. And your class has over 165. So we just give it another 5 minutes before we can start. Sorry? So in the meantime, if you're not speaking, kindly switch to mute. Thank you. And try to encourage others to join because we are starting at exactly 10 minutes past 10. Thank you. All right. It seems others are late. I'm assuming everyone got the communication or the invitation to this lecture. So for the purposes of improving our bandwidth, maybe we can switch off the video it is usually, it improves the process. Thank you. Um, remember we had covered a big chunk of on this course. So I'm recording. Let me just resume recording this lecture. For those, I'll share a link at the end. So, but if you have, I'm getting feedback. Can you switch to mute, please? Thank you. Someone is not switching to mute. I'll just post mute here. Can you all switch to mute, please? Okay, let me just mute all of you. It seems some people don't know that capability on Zoom. So anyway, today I want us to talk about other verification and validation approaches and methods, and overall concept of project management. We started off by understanding what is software development, why it is necessary. Our journey took us into phases of software development life cycle, which I believe you are very conversant with, and system development approaches. By the way, I'm assuming that over the last 6 months you've been actively reading about software development principles. So, system development methodologies or models, software systems engineering process frameworks, agile methods and techniques, software design and construction, system integration, which is something I asked you to read about, quality management, technical reviews. I gave you something to read about it around there. And then we are covering other verification and validation approaches and methods, and project management frameworks and activities. I hope you are aware that our exams are happening soon. So when is the deadline? When are we starting exams?
12th November.
Yeah, so which is just 2 weeks away or 3 weeks away, if you will. So this serves as your last lecture, just to ensure that we cover what is left. So if we talk about project management, it has about 5 areas that you need to think of. That is measurement and the metrics, estimation, risk analysis, schedules, tracking, and control. And so the characteristics of managers by type of team. So we have different types of teams that are set up. Can you switch to mute, please, if you're not speaking? Thank you. Mute. To mute, you do this. Probably I can give you a quick tutorial. You right-click on okay. So on your interface, if you are to mute, just select this, and it gives you the option to mute or unmute. So only unmute if you've got something to ask. Kindly. I still see people who are still unmuted. So the feedback irritates me in the background because I'm using earpins, so it just comes directly. So, but when you have a comment, there's a capability of raising your hand, so I'll check. Or you just say, I've got a question. So, we have random teams. So in random teams, a respected member of the team is used, and he's a charismatic leader. He does not give orders. And we also have open teams where we've got a surprise structure that helps keep the team. Oh, okay. Yes, Jablon. You've got your hand up.
I wanted to ask, is the seeing on our screen, is this the screen you intended to show? But we're still
Which one?
seeing the coursework screen description.
Oh, okay. Sorry, I thought you are seeing this.
Oh, okay. Now I'm not seeing the slides. Thank you.
Oh, are you seeing the slides now?
Yeah.
Yes, please.
Oh, okay. Sorry, I thought I'd shared it as well. Sorry, my my bad. So, in open teams, there is a supply structure that helps keep the teams focused. So we have team players, but also facilitators. So we also have closed teams where there are strong leaders who give clear directions and they manage by results. So, okay, someone on Bizonto, please. We can hear your Bizonto story. So let me just mute all of you. It seems people don't know the capability of muting. So, okay, I think that's better for all of us. So we have closed teams. They've got strong leaders who give clear directions and they manage by results. So we also have asynchronous teams where you've got a visionary leaders. They observe and monitor performance and watch for changing trends. So none of these paradigms is ideal for software development. So software development requires rather complex analysis, innovation, predictable and routine tasks. So for structured open teams, there's a hybrid of team paradigms. There's a combination of closed, that is formal or fixed, or hierarchical, and then some sort of open where you've got shared and flexible egalitarian paradigms. So it
Okay.
uses formal structures to promote flexibility and efficient problem solving. And the catalog of essential teams and roles are used, plus formal specification of non-functional roles and default assignment of roles to assure essential functions are performed. So there are also rotational roles. So today you can be a quality assurance analyst. Tomorrow you can be a developer. So those kind of roles. So and then they organize continuous record of what the group does in a structured and centralized group memory. And it's sort of they are clear and simple external accountability. And technical consensus building is involved in addition to promoting of personal ownership. In most cases, most people don't want to own, to take ownership of the group's performance. Last time I went to a shop, as an example, and I was buying something. So the lady at the front desk told me, if this does not fit, they won't refund you your money. And I was like, they won't or we won't. So is this person part of the business or is he seeing themselves as just an employee? So that was quite baffling. So if you say they, so it means it's management. Her as the employee, she's not concerned. So this happens also in software development in teams where people don't take ownership. If a bug happens, they say it is this one who developed that, or instead of owning and say that was something that an oversight that we didn't see in the beginning, we shall address it as a team. So that is called ownership. Even in a home, you protect your own. You assume even if it's not you who did it, you don't have to do finger pointing to say it's that one who did it. Rather own it up and then see how you roll it out. So who is a project manager? The project manager, they decide on the process model, define preliminary plan based on a process model, and decompose process in adding details to the plan. So what we mean by a process, I think if you remember what we talked about, their development processes that happen. So it's the project manager, in this case, who will decide, are we going agile? Are we going traditional? Are we going to use a hybrid? And then how would we plan depending on the process that we've selected. So there is melding the problem and the process. Sort of you choose a process model, you adapt common process framework to the process model, and the common process framework defines the framework activities that apply to all software projects. And you have task sets as a collection of software activities, software engineering activities, where you've got project milestones and deliverables, and you adapt frameworks to the software engineering project and the team. So an example of a framework activities must include customer communication. So what will be your communication strategy on the project? Planning, how are you planning? Are you going to have detailed planning, or you're going to have just high level? You plan for one component, identify risks, see who is going to work on it. So do you incrementally plan? When you do risk assessment, do you what is the risk assessment framework that you're using, and what are the mitigation strategies for each risk that you've identified? So when you look at construction and release, how will you be churning out your builds? And then customer evaluation. What strategies are you going to use for your customer evaluation? Are you going to use user acceptance testing quite early? Are you going to have demonstrations that are happening quite frequently in addition to that? So it's important to create a matrix so that the major problem function in the framework plus its activities are plotted, and then you have tasks against it. So the project manager must estimate resources, requirements for each cell, and you start, Timothy, probably you can switch off your video, thank you. You start an end date of tasks, deliverables, and to be produced, among others. So that is sort of your planning. So another concept within project management, which is the 4 Ps: the people, the product, the process, and the project. So you cannot talk about project management without understanding the four. Who am I going to use on the project? Which product are we building? What process are we following? What is the actual project we are working on? So for the people, it's the most important element for the success of the project. The product, that is the software to be built, and the process, it's a set of the framework activities and software engineering tasks to get the job done. And the project, that is all the work required to make the product a reality. Remember, we spoke about software being intangible. So you are getting these ideas from the customer, and then all of a sudden trying to make them, turn them into a product. So that's the product. So the project is ensuring that you understand these requirements, design and build something that is reflective of the need that has been communicated to you. So the people that build it and their selection and organization is critical for the success of the project. And the process that you follow in building the product is also important. So your project management skills are quite important in driving this home. Anyone with a question so far? All right. Oh, did I mute all of you? So you just raise your hand, and then anyone with a question? Okay. So the Software Engineering Institute has developed a people management capability maturity model. Is that for me? Just raise your hand. Jesse Jeremy, if you're confused, just raise your hand. So the Software Engineering Institute has developed a people management capability maturity model to enhance the readiness of software organization so as to undertake increasingly complex applications by helping to attract and also grow, yet motivate and deploy, at the same time retain the talent needed to improve their software development capability. So it is aimed at firstly, sorry, I'm checking the charts to ensure that everyone is following. I know you are in technology, but it could be challenging at some point. So I check if it is addressed to me. Okay. So when you talk about attracting, that is, how do you get the right people to your organization, the right skill to your organization, to your development team? Then how do you grow them? So you may find that probably they are half-baked, but they are good guys who can learn very quickly. So which processes do you have in mind, or as an organization, to ensure that you grow them to the level that you want them to be? And then how do you motivate them? Mostly, morale is quite something important in software development. So most people get depressed maybe because of lack of doing something that excites them or challenges them. And at times, most people tend to tilt towards the financial aspect. The other one is earning that, I'm earning this, and I'm doing quite a lot, I'm more qualified than the other, but yet you all came into the organization on different terms and conditions. So, how do you motivate your teams regardless of everything? Now, you see that with COVID or we've got the new normal of doing everything online. So organizations who are still on the traditional way, getting employees to come in and do work, yet most of the work could be done remotely. So you are not improving the work environment. So you have to make sure that everyone is working together. And then when you've got a team that is functioning, how do you ensure that you retain without letting them go? It's always a characteristic in software development. Team members always change jobs at least every 2 years. It's highly likely. But when you're in my age, over 40, there is no reason to keep on changing. So, but as young as you are, so that is something that you keep in mind if a project manager, that over after a year, it is you'd expect someone to change. By the way, as caution, since most of you are not yet practicing, when you have a CV which shows that every 6 months you are changing a job to another job, then your chances of getting into an organization are quite slim, because it is something that they'll be looking out for on your CV. They want to see how loyal are you with an organization. Do you stay for more than a year? Do you stay for more than 2 years? If it's not a fixed term contract. So um, uh, the people management maturity model, it defines recruiting, selecting, performance management, training, compensation, career development, organization, and work design atop the team and culture development. So before a product can be planned, you need to understand what are the objectives upon which this product is being developed and what scope are we looking at. So there are alternative solutions that should be considered in case before you just deciding on building one. So can you look at alternatives? So what are the technical and management constraints that you think of that would be blockers on the product? And also you've got to estimate the cost quite effectively, identify risk, and also have a realistic breakdown of project tasks which are manageable. So for the process, you provide a framework for which a comprehensive plan for software development can be established. So you can have subsets, tasks, milestones, work products, and quality assurance points at any point within the project, and look at umbrella activities, which are software quality assurance, software configuration management, and measurement. So for the project, you have to manage the complexity that happens. The complexity usually spans different dimensions, stakeholders who are quite complex to manage, team members, and the environment which changes. So imagine you are just managing a software project, and then the lockdown happened. How would you manage that? And you've got deadlines. So you need to ensure that as you avoid failure, and you have to develop a common sense approach for planning, monitoring, and controlling a project. So I believe some of you will end up being project managers. So, but there's a detailed course on software development, project management, or overall project management. So for the people, they are the key players. You've got team leaders, the software team, and those who do coordination and communication issues. Yeah, last time there is, I believe you do a course on communication skills, something like that. I recently received an email from a student. Oh goodness, it was quite deplorable. So how you communicate determines how the other person on the other side perceives your character, perceives your basis of speaking, and how you value or rate the other person. Do you believe I'm your equal on the other side? Do you believe I'm your servant on the other side? Are you instructing me? Are you requesting me? So there are many ways that you think. Of course, as a project manager and in terms of communication, often you find that you may be pushed in positions where you've got to place a request, where you've got to demand, where you've got to be rude but stay professional. So how do you build that skill? So that is an aspect of communication skills, but I just wanted to highlight it as a people issue when it comes to project management. And for the players, they have 5 categories: senior managers, the project managers, the practitioners, the customers, and end users. So the senior managers define the business issue, and the project manager does all the roles that we've defined above in terms of planning, motivation, organizing, and controlling the practitioners. So the practitioners, this is the actual team that deliver the technical skills, and the customers, these are the ones that specify your requirements for the software, and then the end users who interact with software once it is released. So we shall go deep in this when we do requirements engineering, if I take you in requirements engineering in a year's time. So the team leaders, we've got, it's rather a people intensive activity. It needs people with skill. So you need to look at motivation, organization, and ideas for innovation as key for leadership. So the team looks at the number of individuals versus the number of tasks. So it's sort of a one-to-many relationship. So you can have decentralized teams which are democratic, controlled decentralized, and also controlled centralized. So it's a bit of a mouthful, but let's see what each means. So with this democratic centralized, there is no permanent leader. Rather, there's task coordination, and the decision is made by a group by consensus. So I see a chat. Raise your hand, Brian. That's how it works. So with okay, I'll answer that. Customers, these are the, all right. Okay, now I'm responding to your question, Brian. You've asked what's the difference between customers and end users. So I've mentioned the customers are the ones that will define the requirements for you. We need a system that must do this, must do ABCD for this to happen. End users, those are the actual users who will be using the system. So if you are developing a student management system, for example, your customers for the university, your customer is the university, which gives you the requirements determining how the system should work. The end users are the students who will be using it, or the university employees who will be using it. So the management, university management, dictates how the system should work. But the end users, they are the people who get their hands dirty in using the system. So if you've been doing registration, the university will define how registration should work. But the end users, these are the actual registrars who do the actual registration, and the students who will be using registration. Does that make sense to you, Brian? Okay, any other question before I continue? All right. So, in democratic centralized teams, there's no permanent leader. Rather, there's a task coordinator whose decision is made, and decision is made by group consensus. Okay. For controlled centralized, there's a defined leader, and decision remains a group activity but there is work is partitioned. And for controlled centralized, there's a top level problem solving process, and there's internal coordination. So some of the 7 project factors that you need to consider when planning include, okay, yes, Jablon.
Okay, previous slide. I have a question on the previous slide. Yeah, that's the control decentralized way of organization. Could you shed a little more light the control decentralized?
Okay, controlled decentralized, if that's what you're looking for. We've got a leader. In that kind of setting, there is a leader who must take ownership, but the decision remains as a group activity. So all members are involved in deciding, should we go on or should we stop? So you seek consent from the group members, and you tend to partition work other than giving it to, maybe you can create subgroups within the team other than having entire team working on the same piece. But the key thing here is the decision-making process being an overall group activity than resting within the ambit of the team leader. Make sense?
Okay. Yeah.
Okay. So you need to assess the difficulty of the problem that you are addressing as a factor in planning. You need to look at the size of the resultant program. You need to look at the time, the degree of the problem to be modularized, the required quality and reliability, the rigidity of the delivery date, and the degree of scalability. So if you are to negotiate a project or a contract on any of this, you'd want to understand these are the negotiation ground, if you will, that you may think of. How is the difficulty against size, against time, and then what is required, what is the measure of success that is your required quality measure from a customer's perspective, and then is the deadline a rigid one, or is it something that can be flexible, and then how scalable is this that we are working on. So there are many reasons that software projects get in trouble. Some fail to scale, others there's uncertainty of the product working, and interoperability having an issue, where by interoperability we mean how the system can work with other systems as an integrated system that can accept data input from other systems, and also it can send the export data out. So you must establish methods for coordinating the people to ensure that at least your project or your product scales. You limit or mitigate uncertainties on the project, and interoperability is enhanced, either designed for it or it is part of scope that it must do that. So in terms of coordination and communication issues, you need to establish formal and informal communication among team members. For instance, I don't think you can communicate a change request on a software project using WhatsApp. I don't think that would be a formal communication channel. Rather, if you want it to be tracked, because this has got a connotation in the contract, you structure a proper email looking at your discussion that leads to this change, the impact, the deadline implications. So trying to create flesh around it so that everyone understands, and whoever has to make the final call at least understands the perspective from which you're coming from when communicating. So it's better to be formal, and of course there could be some impersonal approaches depending, but software engineering documents and deliverables and technical memos are quite some formal ways to deliver or communicate. So you could also formal and interpersonal procedures. where you've got quality assurance activities, status review meetings, and design. And you have informal yet interpersonal procedures like group meetings. And there is electronic communication, which can happen either ways. And you've got interpersonal networking, where you've got interpersonal discussions with outsiders. So for the product, there's always a dilemma in terms of quantitative estimates, but no solid information, software scope, and problem decomposition as key fundamental areas that hinder progress on the product or and the overall project. So for scope, it is the context. It has the information, objectives, the function and performance of the software scope, which must be unambiguous and understandable. So if an example, if we are scoping something to handle examinations, so you'd be asking to what depth and to what breadth should exam handling? Yes, sir. Jablon, your hand is up.
So, if you could just go back 2 slides back. That is, you went through this a bit fast. I was going to take a little more time.
Sorry?
Went through this a little fast. I was requesting people to take a little time with it, especially the interpersonal networking and yeah, interpersonal networking. Also, on the next slide, I had a small question to ask there.
So you have a question about interpersonal discussions with outsiders or interpersonal networking?
Personal networking. Okay, that's all
Interpersonal
last
networking.
slide. Yeah, the whole last slide. Personal networking and also discussion with outsiders.
Okay, let me just summarize it this way. If you've got a project that must run, by hook or crook, you must ensure that the project is successful. So there are ways you need to get decisions much quicker without following the formal process that can happen on a project. There are instances where you've got to follow the formal process to get a decision to be made. Remember, software has to be, there's a coordination between the client and the vendor. That's the relationship that happens. Even if you're a software development unit within an organization, you are the vendor because you are the one who is providing the solution or developing the solution. So if you've got to wait on management to make a decision on something that is going to impact the task which is happening in the afternoon, you've got to devise mechanisms and communication skills or techniques to get this decision driven fast. So you can create interpersonal networks where, this one, if I speak to this one, you can get this decision done quite rather quickly. That is the interpersonal one. So it means, can you easily get along with people and create discussions and networking to ensure that you derive certain decisions going forward very quickly. So, and as you communicate, some will require I think you need to raise your hand. Uh, okay, I'm assuming you are Hassan. So you're saying I'm reading fast. Okay, I'll slow down a bit for the next slides, but I'm trying to summarize this one where the question has been raised. So in interpersonal networking, you've got to develop techniques of your communication. So if you say we shall be using Skype, and I can just drop a line for someone to make a decision very quickly, that is accepted as a tool that you'll be using for some sort of informal communication. And then you can later on describe it in email as a formal communication where you are creating you are formalizing your request or your decision. Does that help you to understand the blocks of formal yet impersonal approaches. So if we say formal and impersonal, you are using the actual deliverables that we use in software development, that it is not targeting anyone, but it is going out for whoever is concerned about it. So when it is formal and interpersonal procedures, uh, you have to say something?
No.
Okay, so if it is formal and interpersonal procedures, uh, this can include like quality assurance activities and your status review meetings and design, where you expect people to sort of express their beliefs, emotions about design and how they want it done. So how would you structure these meetings, and when and in what structure? So when you talk about informal interpersonal procedures, you've got these group meetings where minutes should be taken, and you've got to see how this should be managed. And then the usual electronic communication, where I gave you an example. So how do you communicate? If I may ask you, in an email, do you use dear sir or madam? Okay, if I want to make a request to um, I'm just testing your communication skills, all of you. If I want to make a request to a company, but I don't have any contact in that company, but I've seen an email for contact which says info for anything, info at blah blah blah.com. So if I'm sending an email, how would I introduce this email for the request that I'm making?
Yes, sir.
Dear sir, how sure are you that the other person on the other side is a male? Yes, sir. Jablo.
From my experience, sometimes we do dear sir or madam or dear all.
Uh-huh.
Sometimes we say dear all.
They are all.
Yes. Or dear sir or madam.
Uh-huh. So I'm seeing people who are raising their hands, about three. So can you go ahead? Okay, you watch I will mwana. Okay. So I think all right. Please mute if you're not speaking. We don't want to share your background conversations. Thank you. So I think you when you design websites, and yes, Maria. Maria, you had your hand up. Uh, Should I continue?
Yes, continue, sir.
You're hardly
Okay.
running.
For when you're designing systems, it's important now, if you're designing websites, see how you ask your customers to give you feedback. So I may not easily assume that by reading your name you are male or female, especially in the African context. You realize that in some cultures, because of Christianity or religion, you can tell that this is Hassan. It has to be male. Jocelyn will have to be female. But you can find someone who is named as John Jacobs. So which is the surname, which is the first name. So anyway, that is something in your communication that you can consider. So how do you address it? So if you go back to where you don't have any person that you know, so probably you can say to whom it may concern. But if you say dear sir or madam, that is going to be very formal. In what you write afterwards will be very formal. But if you say to whom it may concern, I've been browsing your website and I identified you do this and this. I would need to get further email, further clarification on this and this. These are my contacts. Please redirect this for whoever can help. Thank you. So you see, I'm just being informal, but if you say dear sir or madam, then I would go blah, 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 blah. Anyway, I don't want to dwell on that. I hope that can give you a glimpse of what can happen there. Okay? Okay. To the next slide now. For the product, scope is always an issue. And if you've heard about software project failure, there is always a notion of a scope creeping. So you start here, and then say you want to build a 2-bedroom house, but you end up building, at the end of your construction, you end up building a mansion with 12 buildings. So the customer keeps on changing. Software happens that way. That usually, if you don't manage the scope, you tend to lose out on the profitability as a vendor, and also you tend to have issues in terms of how successful the project is in driving business value. So you need to ensure that you decompose the problem atomically to ensure that you get to the granular level so that you can understand what the nature of the problem. I recently got a person who was passing an opportunity to me for a client who wanted a system, but they were saying, look at how this system works, look at how that system works. There were 4 systems that I had to compare, and then I want one system that aggregates all that functionality in one, and I want it deployed as in this kind of technology. Those are the terms of reference. So I was like, okay, thank you, but that is quite highly risky as a project, because you don't know what your requirements are. You don't know what how the internal working of the other system is. So how can I understand that the other product works this way? I can see externally the behavior, but I don't know the internal construction. So I cannot give you an estimate based on what I see. So anyway, problem decomposition, it helps you when you're doing your requirement analysis, and when you craft mechanisms of helping you create sort of understanding using the high level information available. So within scope, we usually want to understand what are the objectives in terms of why is the organization doing this project now, how are they intending to achieve benefit out of this project, what problem is it solving, and what will it fulfill in the end. So the objectives are around that. So you look at the functional and performance in terms of what are functionalities are considered in scope, and what are performance issues expected. So all this should be unambiguous and understandable. So in problem decomposition, you have to be elaborative in a way. So if you remember, the rational unified process has what we call an elaboration stage, where you do analysis, deep analysis of what the problem is. So, but in core software requirements analysis, we do functionality analysis or functional decomposition and process analysis. So these are things that we'll tackle when we get to requirements engineering. So where we understand information flow or exchanges. I recently got someone who asked me to help on the project that they're working on somewhere across the border, and they are looking at reimbursement, the process of reimbursement for insurance patients. So they want to see how the different health sector players do the reimbursement process. So if I talk about reimbursement, if you're health insured, you've got a card. So if you go for health services, your method of payment is by insurance. So at the end of the day, you'll have either to claim in case you make extra money out of it, or the insurance will have to claim from your employer if they deducted money, regardless of how the structure is. So reimbursement works in different ways. So if you are to understand that process, you need to know who is the participant, where does the information start to be generated, where does it end, who is the final recipient, and the functional decomposition. You look at what happens, which functions actually are driving the process from start to the end. So for the process, there are generic phases that characterize the software process in terms of definition, development, and support. So the problem is to select the process that is appropriate for the software to be engineered by the project team. You remember we spoke about are we going to use agile, a hybrid, or traditional? Most of the time, it could be a mix, not purely agile. So, as a project manager, how do you decide on the process? So, once you decide on that process, do you think it will help you arrive at where you're going to go? So, if you've seen how roads are being constructed, take an example of the Northern Bypass. I believe all of you have used that road. It is something that I think they started constructing that road around 2005. And 15 years down the road, it's not yet. Anyway, so if you look at how it has been constructed in terms of what is the process that they're using, there's backfilling, they are creating bridges, then they divert from one side to the other, traffic is diverted. Then they started with circles. Now all of a sudden, those resources are wasted away. They are removing the circles to elevate bridges for intersections. So are they changing the process of development? Why didn't they start with that in the beginning so that they can create a two-lane which is functional, and then build the next two-lane when they have planned for the intersections properly? And have you realized that lighting system is only by the intersections? Elsewhere it is so dark. So anyway, those are things that you can think of. So when you choose the process of construction, how do you do it? You've seen buildings, how they are constructed. Some, if it is a storage building, they may want to just start with a foundation, build the first floor, and then make finishing for that so that it is habitable. Then they continue construction when they have tenants or it is occupied. So again, that's the process of construction. So there are those who just buy all the material, dump it by the site, and they start construction. Yet there are those who keep on buying. As materials get finished, they keep on buying. So it's a process. So it is the same with software. We can use linear or sequential models, which we discussed earlier. We can do prototyping. We can do rapid application development. We can follow a process for incremental modeling, spiral modeling, component-based, concurrent development modeling, or formal methods, or we can use fourth generation techniques, which we covered in the previous lectures. So you must decide which model is the most appropriate for you in terms of how the customer will understand your development process and the characteristics of the product and the project environment. Out of experience, I've seen that what customers worry about most is how much and how long, in terms of when are you going to deliver, so that they can anticipate and prepare other change transition processes within the organization, and also start anticipating the value that the system will create. So if you've been managing a manual system to record transactions, and then you tender someone to develop a system for you, you want to know if it will be delivered in February. From now onwards to February, development is happening. Regardless of how they are developing it, it does not matter much. What matters to you is that come February 20th, the system is delivered. So you know training will start, and you know that at least by April it will have stabilized. No more paper manual recording of transactions. So if your customer can understand how you're going to perform your software development, so the process, if you explain it transparently and to the detail so that they can understand if it's incremental, why? If it is spiral, why? If you're prototyping, if it's rapid application development, regardless. What they're interested in is, have you developed the product and are you sticking to the deadline? And the characteristic of the product, how is this product and what sort of hindrances and what is it trying to solve. And then project environment. We've had COVID here and the countries were taken by storm. So they were looking for different applications that can run very quickly. So there was no room for this, for sort of discussing deadlines with this. So if you're looking at disease surveillance tools, for tracking patients. So if one would develop that, this is something that would be required to be developed in such a high turnaround time. So for the project, you must understand what can go wrong so that problems can be avoided. So there are 10 signs that can indicate that projects are in jeopardy. One, when software people don't understand their customers' needs, or when you fail to agree on what is perceived as a need and what is sort of desired as a need, and there's product scope is poorly defined, changes are made poorly and most cases informally, the changing technology the chosen technology changes, the business needs change, or they are ill-defined, they are unrealistic deadlines, users are resistant, sponsorship is lost, the project team lacks people with appropriate skills, and then you've got an issue with managers who avoid best practices and the lessons learned. So these are just symptoms of a project that is in jeopardy. So if you don't manage any of the 10 areas well as a project manager, you are tilting towards a failure on a project. But there are some five sort of part common sense approaches to software project management. You have to start on the right foot, maintain momentum, track progress, make smart decisions, and conduct a post-mortem analysis of the project. So if you start on the right foot, you need to ensure that you understand the problem. So you need to use skills that help you get that right. So that you can know that you are building the right product, which will solve the problem that is anticipated, and that this product aligns well, or the requirements that you're defining the program aligns well with the vision for where this product will take this organization. So maintaining momentum, it is on both sides, the clients and your team. If you've managed a project which happens over 3 years, you find that the momentum that people start with, especially customers, it tends to wither off with time. And maybe the person who started off as the champion of this has left the organization. So how do you maintain momentum to get them excited still about this product, although it is taking long? And then how do you maintain momentum within the team that is developing this? So it is also important to track progress by understanding how far have we gone and what is still left. And you need to make smart decisions and own them. Once you decide, make sure you stick by it and also keep it simple. And it is plausible to conduct a post-mortem analysis. Look back and reflect on the history. How did we do it? What happened? What did we do wrong? What is it that we should have done? We shouldn't have done. How best can we do it? How can we ensure that we don't repeat this? if you've worked in organizations that are practicing Scrum as a part of Agile methodology, there's what we call, I'm just missing the name. There is a session which handles this postmortem analysis for each sprint. I'm forgetting the terminology that they use. But at the end of each sprint, there is a session. Yes, Deblon.
So thank you for your question. Now, I ask these procedures that project manager must go through most of most of the procedures you'll discuss based on getting to know what the organization really wants, or relying heavily on customer really wants. So how about I wanted to ask, how about if you're just innovating? Let's say you're not developing it for an organization, you're developing your software maybe go direct to the end users, not through the customers as you have mentioned.
Again, you are assuming that you're developing your product as an individual, if it's an innovation. But that is an entire
Yes.
dimension because you're not managing it as a project. It's research and development.
I beg your pardon?
You are managing that as research and development, not as a project. Project management, you've got a client and a vendor providing, so they're meeting. But if it is your research and development, you say, probably let's try out something like this, see how it works, and then let's test it with the user and get feedback. So that is the research and development. You keep on experimenting and going back to the users and see how they perceive it. You don't have an actual product that you're selling. So if you'd want to sell an actual product, which is matured, then basically that is a marketing issue. It's not project management. But if you are being asked to customize that product, given how you've demonstrated the capability that it has, even if it is out of research and development, then that becomes a project because now you have a customer on the other side and you are the vendor on this side. If you've seen most of the open source software that happens, they have got licenses for premium, blah, blah, blah. So basically, they first try it out with everyone working on it. They get feedback and the issues that are raised. So basically, they allow for others to test the system for them. And at the end of the day, they start commercializing. If you need this kind of feature, then you need to pay this much for this for this period of time.
Okay. Yeah.
Makes sense?
Yeah, it does make
Okay.
sense. So I was really asking if you have followed the procedures of what a project manager has to follow, the procedures that a project manager has to follow to develop for an organization when the developer is only just developing for the end users, or is just innovating, or is just trying to solve a problem that is actually somewhere out there, and developing something which is new and putting it out there. So we follow the same
Okay.
procedures.
I I think you must understand that the biggest challenge we have is trying to combine all the roles into one. I think this was in our first lecture where we mentioned that software is developed in teams. So if you're an individual doing project management, quality assurance, requirement analysis, testing, training, deploying, configuration management, you are putting everything into one basket. So there is no way on earth you're going to follow project management steps.
So there you need to get a team.
Absolutely. So what I'm trying to say that you cannot say you are developing or practicing standard software development when you're just an individual doing the roles of all the other roles of other team members. So it means you're not going to be effective in testing, in designing, in understanding the users, in training them, and supporting the application. You're overstretched. Make sense?
Yeah, understood.
Okay, so on point five on postmortem, so they call it a retrospective. So a reflection of what has happened. What did we do right? What did we do wrong? How should we have done it? What can we do in future to make it better? What lessons did we learn? So that is postmortem analysis. So any questions on project management? It's just a concept, but there is a detailed course on project management. Bear with me. So this is just introduction to give you high levels. Any questions from others? Okay, I want to jump into verification and validation. So we usually reflect on two things. Are we building something right that fits the problem? And are we building it right? So verification is about ensuring that we are building the right product. And validation is about understanding how best we are building. Are we building the right? How are we building the right product? That is validation, verification. Are we building it right? So there is a whole life cycle process for verification and validation, which can be applied at each stage within the software development process. But there are two objectives here. It is how you discover the defects and how to assess if the system is useful or unusable in an operational situation. So if your system is buggy, so how do you determine that it is buggy? Then, is it making sense to the end users? So I think someone raised a question about the difference between, that could have been Hassan, the difference between customers and end users. So the customers dictate what the requirements are. So in case it's the top management who want change that the solution is going to create or drive. But the end users, they're the people who will use the actual system. So if they're not prepared well to adapt to this change, they may not find the software useful. So they may want to continue using the traditional methods they are used to without necessarily adapting to technology. So, but the goal is you need to establish confidence that the software is fit for purpose, that it will solve the actual problem anticipated. It does not mean that it will be completely free of defects. You see, even Microsoft still has some issues, though they have been around the market for a long time. So, what rather you must focus on that it is good enough that once it is being used, there's some degree of confidence that it won't disappoint users. So, confidence depends on function, expectations, and the market environment. So when you talk about function, it's the level of confidence which depends on how critical the software is to an organization. And user expectation, we are meaning users who may have low expectation of certain kinds of software, believing that it is not going to contribute any value of some sort, and this could influence quite a big majority. And the market environment, understanding the dynamics. If you send out a program that is buggy, then your competitors may may capitalize on that, and then you don't have sales. So if you are on a research and development project or product, and you want to take it to the market, at least with that particular problem, targeted problem, and the That's why you're seeing a strategy of having open source licenses until the product matures. So to do this, we have static and dynamic verification, uh, which has some processes. How do we inspect the software is part of it, and how do we test the software? So inspection is regard to the analysis of a static system so that you can discover problems that are associated with it. We shall dig a bit deeper into this. So for testing, you are exercising and observing system behavior based on some inputs and to see how it responds. So that's the difference. Inspection is more of, let's take a walkthrough, let's look at design, let's review the code, let's review the requirements, what do you think the issues are, what is the, how about the architecture, etc. That is the inspection. And then for testing, you are actually inputting inputs into the system and then observing how the system reacts to track and see if there are defects. So both of them are used in tandem. So when you talk about testing, it's the real, you want to ascertain if there the real presence of errors in the system or they are not there. So the only validation technique for non-functional requirements as the is to do testing so that you observe how the system performs. So if you want to upload a file and it takes forever to upload, there are things that you maybe or you don't even show the user that the system is uploading. So how do you evaluate the quality and performance? So non-functionally, you can only test the system to see the behavior of quality attributes. So it should be used in conjunction with static verification to ensure that you provide a full validation and verification coverage. Again, you've got a course on quality assurance and testing along the way, which will go deep into this. I'm just introducing the concept. So we've got different types of testing: defect testing, validation testing. In defect testing, your tests are designed to discover the system defects. So a successful defect test is one which reveals the presence of defects in a system, and that is covered later on when you look at Pressman. So validation testing, it is intended to show that the software meets its requirements, and a successful test is one that shows that the requirement has been properly implemented. When we do testing and debugging, they are distinct processes. So we need to establish if defects are in the program. So debugging is concerned with locating and repairing. And it also involves formulating a hypothesis about a problem behavior. Then you test these hypotheses to find if there is a system error. But you need to plan how you are going to do your verification and validation exercise. It's not something you just say, let's just test the system. Rather, you need to plan for it and put it as part of your project plan. So careful planning is required so that you get the best that you'd expect out of testing and the inspection process. So you should start early into the development process. Actually, we also do a test on requirements, if you didn't know. So when you do requirements engineering, that is something that we shall discuss. So how would you test requirements? And how do you test specifications? So that is the role of quality assurance on the product, sorry, on the team. So the plan should identify the balance between your static verification and testing, and you need to decide on the standards of and the testing processes other than just describing product tests. So are you going to use any tools? Will you do regression testing? Will you do white box testing? Will you do, so all the different kind of tests, which I don't want to go into, which you'll find in quality assurance and testing course. So, but just to give you a structure of what a test plan is like, you've got what test process you'll be following, the requirement traceability. Requirement traceability is all about understanding how the requirement has been defined, how it has been designed, how it has been developed, how it has been tested, has it failed, has it passed, which associated resources define that requirement, and how can I link it to the lower level areas like code, like design documents, like specifications. So it could be backward or forward. So I can start from code going up to the requirement, or I can start from a requirement down to a test case. So you need to look at the tested items in your plan, the schedule of testing, test recording procedures, the hardware and requirement specifications that you use for your testing, and the constraints. So when we talk about inspection, what does it involve? Inspection involves people examining the source, representing with the aim of discovering anomalies and defects. So if your source is specifications, so that you'll inspect the specifications and expect to come out with a report of what you found, if you assume it is the source of where the errors are. So if it is code, the same can happen. It does not require execution of the system, so it may be used before implementation even. So that's the issue with requirements and specifications. So they can also be applied to any representation of the system in the range of requirements, design, configuration data, test data, among others. And it has been proven to be an effective technique for discovering program errors over time. So the issues here is how should it be successful? You could have many different defects that are discovered in a single inspection. So when you test one defect, you may mask another. So several executions are required to ensure that you unmask all the others. So if you do an inspection, probably you can achieve more by getting different sources and where different problems are. So you may also be reusing some domain and programming knowledge. So it makes it easier for reviewers, and they're more likely to have seen a similar type before in another problem. So if you are on a common product line, what I mean by product line, so if you're developing HR systems and you get regular customization of HR systems, or you're selling HR systems, as an issue crops out, so your product line of HR systems, you are aware how that issue happens over different programs or over different projects. Or if you are developing applications within a financial sector, so that is the information domain. So you've got your domain is finance. So you've got a fair understanding of where issues arise when it comes to such a component. I hope that helps. So inspection and testing are commonly complementary, and they're not opposed to verification techniques. Both should be used within the verification and validation process. So inspections help to check the conformance with specifications, but not conformance with the customer's real requirements. So are we building the product right? So they cannot check non-functional characteristics such as performance and usability. So this you've got to do with testing. So the program can also be inspected using a formalized approach to document what you've reviewed, and it is intended specifically to identify defects and not corrections, and not even pointing fingers of accusation on why it was done, but rather improving the quality of the product. So some of the defects could be logical errors, anomalies in the code, that could indicate an erroneous condition or even non-compliance with standards. Your naming convention. So you want a method to register, but your use case student register, but your method in your ERD says you've got maybe a function register, but how it is developed in code. So there's inconsistency within your use case, your design model, and your actual code. So how do you track a requirement which talks about registration? So, and the standards, do you have, as an example of coding standards, do you comment your code? Do you sort of close off brackets? Are you creating tries for catching exceptions? All those are things that you can think of. But again, I'm not speaking about coding standards here, but things that you can look out when you're doing standards. So the preconditions, if you're going to do code inspection or inspection, is you must have a precise specification which you're going to use, because you're basing on that to accurately determine if what was specified is what is developed. So when you don't have specification, it makes it difficult to do inspection. And I've seen quite a number of projects where they've got code, but they don't have specifications, or they don't specify their requirements to the detail. And you just have only requirements and code. So the team members must be familiar with organization standards, and you have to do it syntactically, where the code that is corrected, and also all the other system representations. So you have to do an error checklist that you use to help you collect the errors that you identify. And then management must accept that inspection will increase costs early in the software process, and management should not use inspection for staff appraisal. So rather, or finding out who makes mistakes. So rather, you need to just look at it from a product improvement, quality improvement perspective. So the procedures here is you've got to have a system overview, which is presented to the inspection team, the code and associated documents, which are distributed to the inspection team. So the inspection takes place and discovers errors. You look at modifications that are made to repair discovered errors, and then you do an inspection, which could happen or may not happen, regardless. So you are in a way auditing in terms of quality to that granular level, matching specifications with the code, and then you can later do testing to see how other non-functional requirements are taken off. So the roles here, you've got the author, the inspector, the reader, the scribe, the chairman or moderator, and the chief moderator, each with different functions. So the author or owner could be the programmer or the designer, someone who is responsible in developing that artifact. So the inspector is the person who finds out the errors, omissions, and inconsistencies. The reader is the person who presents the code or the document to an inspection team. And the scribe, someone who takes notes of the inspection results in the meeting. The moderator is the one who manages the process and facilitates the inspection. And the chief moderator is the one who looks at how the process can be improved over time. So by updating checklists and standards of involvement. So the checklist is just, they usually contain common errors and those that should be avoided. But it is a tool that helps you to drive the inspection process. So if you're looking at errors, what do you need to check? Which errors and what on errors are you specifically interested in? Because a system can exist with errors which do not necessarily hinder it from performing or operating. so which you can correct later. So, but if you're identifying errors, are you looking at critical errors or blockers, things that could be embarrassing, among others? So, error checklists are programming language dependent and reflect the characteristic errors that are likely to arise in the language, usually. So, but in general, the weaker the type of checking, the larger the checklist. So, for example, if you're just looking at initialization errors, constant naming errors, loop termination related errors, array bounds, etc. So these are all even pointers, the go-to statements that you use, depending on the level of granularity that you're using. So if not mastered programming, some of these concepts may not make sense to you. So the inspection rate is more of quantifying the impact that you've seen. So if you discover that when you have a code base of about 10,000 lines of code, and after inspection you realize that 60% of the code has got errors, and you must report this to management. It means if you've got to send out such a product to the market or to the client, you need to ensure that you agree on the percentage of reduction of those errors. Should we bring it down to 10% or 5% before we deliver? And if we deliver it as it is, given the deadlines, what is the impact? So will it achieve the objectives? Or what will be the reflection from the end user perspective? And if you are to redevelop and correct those errors, what is the cost? So that's what the rate is all about. So you may want to measure the rate of impact of the errors discovered against time, against resources, against cost. Yes, I'm seeing Jablon, I'm seeing your hand up.
Yeah, I wanted to understand. So this inspection, it is to inspect the codes of the program or just to inspect the functionality of the program itself?
I mentioned that inspection can span or can entail the design documents and also the code itself. So when you do inspection on the code, you use specifications and the code to see if both of them align and to see where the errors are. And this will depend on the error checklist that you're using. So for the functionality, then you will have to do testing to see how the system behaves. Have you heard about the notion of code reviews?
Not yet.
Yeah, code review usually happens that after development, the team lead, the development head, I think twice or thrice a week, they meet up with the team and they do a code review. So each one presents the code that they have developed. It's one way of inspection anyway. They have developed throughout the week, and they present it to everyone, and then they're given feedback on how they have developed it, and they give their own experiences. That is one way of improving how teams work. So code review is that one aspect. So we are not testing functionality, but we are looking at how you've written your code itself. Because one can write the same function with 7 statements, and another can write the same function with just 2 statements of code. So how do you balance, and how do you help someone who writes 7 statements to reduce it to about 3 or 4? So in a way, they are improving their development skills. Make sense?
Yes, yes, understood. Thank you.
Okay. So this I'll skip. You read the arguments for that, but the key points here for verification and validation, you must understand that they are not the same thing. Verification shows conformance with specifications, yet validation shows that the program meets the customer's needs. So the test plans should be drawn up to guide the testing process, and static verification techniques involve examination and analysis of the program for error detection. So when you talk about static, we've got those inspections and then testing. So when you talk about dynamic, we use tools that will help us to track all this and generate reports for us. So program inspections are very effective in discovering errors, and program code in inspection is syntactically checked by a small team to locate software faults, and static analysis tools can discover program anomalies, which may be an indication of faults in the code. And usually there's a clean room development process, which depends on incremental development, static verification, and statistical testing. So that is it that I wanted to share with you with regard to verification and testing. So I've not seen any of you. Can you see my screen still?
Yes.
Okay. I developed this content on Mwele, which has all the slides for this course, software development principles. So if you search by this code 1201, you'll be able to see this this course. So it has got everything, and the coursework is also there, which I'm going to talk about now, and all the relevant articles that we've been. Okay, Mwele is on and off, but anyway, it is available. So I would expect that you start using it, because this is the going in position going forward with online teaching and online learning. So you ought to use Mwele more effectively than there was a proposition actually to teach via Mwele than via Zoom. So something else that I want to highlight is the coursework. You did a test, and also there's an assignment that I gave at the beginning. I think it was in the first or second lecture, but that was rather to get you off the ground and getting grounded into the concept. So you are required to have a minimum of 2 before you write your exam. So I've developed a coursework for you for the second coursework, and the deadline is 28th October. So the intent is that at least before you write your exam, you know what your coursework mark is. So you'll have, I'll display your test results by Monday next week. You should find them on Mwele. And once this is submitted, at least by 5th October, actually not 5th, that's far. By about 4th November, the mark on this should be also available on Mwele. So whoever will have scored below 50, then I would see how I can give an alternative or use the first assignment to push them up above 50. I've, out of experience, got students coming to me complaining actually worked quite very well on their coursework marks. So if you can push to get 100% in coursework, you're more than likely to score quite very well in the exam. But if you score 50 in the coursework and tests, then you're likely to have, if you find the exam difficult, your grades will be quite low. So the coursework that I'm assigning you is looking just at what is the business side of software development. And then I'm putting a context on the structure of how you can speak about it, the business side of software development. There's quite a lot of documentation on this online, so which can guide your thinking. But I'll do a plagiarism check. So if you copy and paste, if you don't paraphrase, if you just reuse someone without referencing, then if I do a plagiarism check, you are automatically disqualified. Does it make sense to you?
Yes.
Yes, sir.
Okay. Any questions? All right. So how have you found
Excuse me, sir.
Yes, please, Olivia.
I wanted to ask a question.
I can't hear you, Olivia. You raised your hand.
Like, have you? Okay, like the screen has gone. Eh? I wanted to ask how many pages are we supposed to write, or in about how many pages? Eh?
It should not go beyond 3 pages.
Okay.
Yes, I've put that detail in. So if you look on Mweli, let me just share this Mweli thing again. Uh, so when you look at, can you see? Sorry, this one is using a guest lecture, so you won't be able to see, but this will require me to log in and log out. Sorry. Let me just, but on the course page, you'll be able to see that I've put a folder for submission. I've put the file for the coursework there as well, and announcements, and it gives you all those instructions, Olivia, and the rest.
Is that, sir, excuse me, sir.
Yes, Jesse.
Is the one
Or
supposed to
is
be
it?
typed or handwritten?
We are using digital ways, so it has to be typed because you're going to submit it electronically. I don't expect you to write it and take a photo of it and then upload it. It has to be typed. It is single space 11 and as far as font 11. I think I specified also the font type. Yes, I'm seeing Jesse Jeremy. Your hand is up.
Just to query, does this bring us to the end of our conversation?
Yes, this is the last. This brings you to the end because we only had one lecture left. So
So
for
all the
the
notes
last
are in
six,
Mwele, right?
Wow.
but someone is saying, "Wow, you people are amazing." So, but I used to share with you all the slides for the lectures that we had. But the good thing is I've uploaded all the slides on Mwele.
Second.
Sir.
Yeah.
So that means like you said, this is the final lecture. That means the other lectures
Yes.
will not be. I was thinking the other remaining lectures are stated in the Google thing. I was thinking we revise what we completely got through from the very beginning. Maybe
You've
yes,
got
take
all.
us through.
I did schedule them that way, but when I reviewed what we had covered and what is left, so I don't think you've got, and the time that you have left the exams, because next week that will be, let's see, that will be 28th. So you can
Yeah,
use, that's the deadline for your coursework. And the other week is 4th, and which leads you to 11th. So you need time, I need time to mark and prepare your marks and also look for those for remedial. So I think this is the end, and you've got enough time and all in the material online to take you through.
Okay, sir.
Ignatius and Emmanuel, you've got your hands up.
So to me, I just wanted to talk about the Mwele,
Sorry?
how Mwele is misbehaving, because at times we open up this app to pick work, but then it loads and loads and nothing happens to come out. So how are we going to account for this? Because at times we try to submit work and then the app fails often. When you try using the laptop, it then fails. Why can this be corrected at the university, since this is now the trend?
Okay, thank you. But unfortunately, I cannot speak on that because I'm not the one managing that. So you can channel that feedback to DICT or to administration. Olivia,
Okay.
Maria, and Emmanuel.
Excuse
You
me,
still
sir.
have, yes, is that Olivia or Maria?
Maria, sir.
Yes.
Please throw some light on the last bit you talked about. My data got done. Please.
Unfortunately, fortunately, I've recorded this session, so I'm going to share this with your class representative. So it's on the cloud. You can download it and listen to the entire lecture.
Like on the exercise, what you want and what. Like all only on the assignment. Because yeah.
Maria, I think you've got plenty of other people around here, so you can discuss with them. It will be helpful for you.
Okay.
Olivia? Okay, I think, is there another question before we close?
No?
Okay, I hope you found this course quite interactive and useful. I hope it has been able to broaden your knowledge. And it was nice having you, and hope to meet again in requirements engineering.
Excuse me, sir.
Thank you, sir.
Okay, thank you.
All right, cheers and good luck.
Yeah.
Thank
Thank you.
you.
Thank you.